Hello, good morning. Can you hear me? Good morning. Can you hear me? Yes or no? Okay, any doubts from the last class? Any doubts from the last class? Good morning. Any doubts from the last class? Okay, so last class we did significant figures and rounding off. So I hope that is clear. So today we will be doing dimensional analysis. Okay, so today's topic is dimensional analysis. So before that we have to understand what is the meaning of the word dimensions. So dimensions of a physical quantity are the powers to which the fundamental quantities must be raised. So physical quantity can be anything like area, volume, force, right? All these are physical quantities because they can be measured. Anything that can be measured is a physical quantity, right? So dimension of a physical quantity like area, volume or force are the powers to which the fundamental quantities must be raised. So if you remember, we have talked about fundamental quantities where I told you length, mass, time, temperature, electric current, luminosity, and amount of substance. So these 7 are fundamental quantities, right? Because if you want to measure them, you don't have to know anything else, right? So that's why they are called fundamental quantities. Okay, so dimension of any physical quantity like area, volume, or force is the powers to which these quantities must be raised to get the dimensions, right? Dimensions are the powers of these physical quantities. Is it clear? So let's see. First of all, I'll show you this table, right? If you can see this table, see these are your fundamental quantities, right? Length, so the dimension of length is L. Okay, just like unit of length is what? Meter. So there is a quantity called dimension, and for length that is L, for mass that is capital M, time capital T, temperature capital K, electric current is capital A, luminous intensity or luminosity is CD, candela. Okay, and amount of substance is mole. Understand? So from where do we get this alphabet? Length is capital L, again M for mass, right? Time is T, temperature is because temperature is measured in Kelvin, so that's why we write K. Understand? But it does not mean that you'll read this as Kelvin, you'll say K only. Is it clear? Understand any doubt so far? Okay, so these are the dimensions of your fundamental quantities. Now for example, suppose area is a physical quantity. Area of any figure, let us say, simply take a square. Okay, area of a square, if A is the side of a square, then area of a square is A square, right? Now A is a side is a length, right? What is the dimension of length? L. So this will be L square. This means that dimension of area is L square. Is it clear? So this is the dimension of area, right? And it is raised to the power 2 for length, right? And I can also write the others. I can write M also here, I can write L also, but since M and L doesn't M and T does not appear in this formula, so M will be to the power 0, T will also be to the power 0, L square. So this is your dimension of area. Is it clear? Yes or no? Is it clear? Are you sure? If it's not clear, I'll explain again. Okay, just like we have units for quantities, we have dimensions. Okay, you should remember that every quantity has a dimension. Okay, understand? So for example, area, I have just showed you that it is M0 L2 T0, right? Volume, now volume of any substance will be cube of a side, right? So suppose you want to find the volume of a cube, then formula for volume of a cube is side cube, right? A cube. If A is the side of a cube, then the formula of volume is A cube. So again A cube. Now side, so A is a side, right? A is the side. Side has the, side is a length, right? A side is a length, so again this will be length cube, right? So this is the dimension of volume. Again, if you want to write M and T, you can write M0 L cube T0. So this is the dimension of volume. Force, let us find for force. So you should know the formula. Okay, if you want to find a dimension of any quantity, you should know the formula. So formula for force is mass into acceleration. Now mass, what is the dimension of mass? I have shown you in this table. Right, so you can see mass is capital M. So for M, for this mass, okay, let me write the full thing. So formula for force is mass into acceleration. Now mass is dimension of mass is capital M. Acceleration formula is velocity by time, right? Another formula for acceleration, because we don't know the dimension of acceleration, it is not given in this table, so we have to make it simpler and simpler. Okay, so let us find it separately. Let us find the dimension of acceleration. So acceleration is velocity by time. Here we know the dimension of time is capital T, but velocity again we don't know. So another formula for velocity is displacement by time. Displacement by time, right? This is another formula for velocity, and there is one more time here, so into time. So displacement is again a length, right? Displacement means what? It is the distance, shortest distance between 2 points, right? So this is displacement, so it is a length, so dimension of displacement will also be capital L. Dimension of time will be capital T, okay? So combine all of them, I will get L. So this will become T square, right? In the denominator it will become T square, and if it comes up it will be T to the power minus 2. So this is the dimension of acceleration, okay? L T minus 2 is the dimension of acceleration. So if I put it in this formula for force, I will get M is for mass and acceleration is L T minus 2. So combining the two, I will get M L T minus 2. So this is the dimension of force, okay? Remember, dimension should always be written in square brackets. So this is the square bracket that you have to write dimensions in. Is it clear, yes or no? Dimension of force is clear, or if there is any doubt, just say, write it in the comment box. Yes, any doubts? Please type your doubt in the comment box if you have any doubts. So dimension is clear. What is dimension? Right. So now if you match this dimension with the definition, see, dimension of a physical quantity are the powers to which the fundamental quantities must be raised. So in this case we found that the dimension of force is, so dimension of force is equal to M L T minus 2, right? So now if you compare with the definition, so dimension of physical quantity, in our case it is force, right? So dimension of force is the power to which the fundamental quantities, so this M, L, T are your fundamental quantities, so it is the powers to which they must be raised. So M is raised to the power what? 1, L is also raised to the power 1, T is raised to the power minus 2. So these are your dimensions. Is it clear? So similarly we can find the dimension of anything. If you want to find the dimension of pressure also, you can do it, right? Pressure, you should know the formula, like I said. So pressure formula is force by area, force divided by area, right? So force we just found, it's M L T minus 2, right? Area we know is L square. So now combining all three, I will get M L minus 1 T minus 2. So this is the dimension of pressure, okay? Like that we have to do. Is it clear? So I just took this L square to the numerator and the power becomes minus 2. So plus 1 and minus 2 gives me minus 1. Is it clear? Yes or no? Okay, so that is your dimensions, okay? Now what is the use of dimension? Okay, before we go, so we have three main uses of dimensions, okay? We will talk about that, but before that we will on the basis of dimensions, on the basis of dimensions, on the basis of dimensions, physical quantities can be divided into 4 categories, okay? Physical quantities can be divided into 4 categories. Okay, so I will tell you the four categories, but before that I will just explain what is constants and what is a variable. Okay, constant and variable. So the word constant is simple to understand. The meaning is the word itself. Constant means which is fixed, something which is fixed, does not change. So this is a constant. And variable means something which changes from time to time. Okay, something which changes. Okay, so constant is something whose values is fixed, it does not change, whereas variable is something whose value will change from time to time. Okay, so that is constant and variable. Now, okay, so that's what I wanted to explain. So on the basis of dimensions, you can have four categories of physical quantities. Okay, so first one is your dimensional. First category is dimensional variables. Okay, so what type of quantities fall under this category? Like area, your force, pressure, volume, all these quantities fall under dimensional variables. Why? Because first of all they have dimensions, right? They have dimensions, and also they are variables. They are variables because area will keep changing, right? Depending on the shape, size, and the thing that you are measuring. Area is not a fixed quantity, it changes depending on the shape. Force also is something which changes, pressure also is something which changes, and volume also is something which changes. So that's why these quantities are called dimensional variables, because they have dimensions and they are variables. Okay, so number 2 is non dimensional variables. Okay, I will give you examples. So angle, then you have something called specific gravity, and strain. Okay, so these things, strain and specific gravity I will not explain now. Okay, just for your examples I am using them, but you can understand this from angle, right? Angle is something which is variable, right? Depending upon so this angle, right? So these two have different size, so they have different values of angle, so it is a variable and it does not have any dimension. Okay, angle does not have any dimension. Is it clear? So two types of variables: dimensional variable which has dimensions, and non-dimensional variables which does not have dimensions but it is a variable which changes. Okay, so is it clear? Yes or no? Is it clear? Dimensional variable, non-dimensional variable, is it clear? Yes, any doubts? Don't hesitate to tell me your doubts. Okay, I can, if I'm am I going too fast or is it fine? Am I going too fast or is it fine? Yes, am I going too fast or is it fine? Are you understanding what I'm teaching? Okay, so those are your variables. Okay, now constants. Now we'll talk about the dimensional constants. So you have dimensional constants. So again, these are quantities which have dimensions, but they are constant, they do not change. Okay, for example, if you have studied gravitation in class 10, right, you know that the formula for gravitation between two bodies is equal to F is equal to G capital M by M R square, right. So this is the force of gravity between two objects whose masses are capital M and small m, right, and the distance between the center is r, right. This you must have studied in class 9, right. So the formula for a force is this, right. Here what is G? G is a constant, it is called universal gravitational constant. If you remember, G is a constant which is called the universal gravitational constant. Okay, so these type of quantities fall under this category. Okay, why? Because this is a constant whose value is G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, so these are your quantities which are constants, but they also have dimensions. Okay, we can find the dimensions from here. We will put the dimension of force, we'll put the dimension of mass and distance, we can get the dimension of G also. Understand? We will see that later, we can find that later, but just understand what is a dimensional constant. It is a quantity which has a dimension but is also a constant, for example G. Then you will have other examples also, which I cannot give you if I give you now. Okay, so I'll just tell you. Then you have something called Planck's constant. Okay, this H is a constant which I think you must have, you learned in class in chemistry class this year, or in physics class next year. Okay, this H is called your Planck's constant. Okay, again this has a fixed value and it also has a dimension, so that's why it is called dimensional constant. Now the fourth and last category is your non-dimensional constant. Non-dimensional constant. So what kind of quantities fall under this category? The quantities which have no dimension but they are constant. For example, pi is a constant, yes or no? It has the value 3.14 in something, right. We don't know that we cannot write the whole thing, so 3.1456 something, right. So this is the value of pi, and then there is something called E also, which you will learn in maths logarithm this year. It's called exponential, right. So the value of this also is constant, 2.7 something, right. So these values are something which are constant, right, they do not change. Pi, the value of pi is same always, and even the value of E is same always. So they have fixed value but do not have any dimensions. Okay, so four categories, very simple. Variables are something which does not change. So quantities which have dimensions, sorry, variables are something which changes, right. So quantities which have dimensions but they also change from time to time are called dimensional variables. Quantities which are variables but do not have any dimensions are called non-dimensional variables. Constants are something which are fixed, does not change in value. So the quantities whose values are fixed but have dimension are called dimensional constant. Quantities whose values are fixed but do not have any dimension are called non-dimensional constant. Is it clear, yes or no? If it's not clear, just write in the comment box, I'll explain again. Okay, so that is your okay. So now we'll learn the three uses of what are the application of dimensional analysis. Okay, so this topic of studying dimensions and using them is called dimensional analysis. Okay, the topic that I have written here, dimensional analysis, is the study of these dimensions and their uses. Okay, so applications. Number one, the first application is to change from one system of unit to another. Okay, so the first use is to change from one system of unit to another. I'll explain that. Number two use is to check the correctness of a physical quantity, to check the correctness of a physical equation. And number 3 is to derive a relation between physical quantities involved in the phenomena. Okay, so we'll talk about each one by one. So let us first talk about this. So first we'll talk about this one. Okay, to change from one system of unit to another. Okay, so we'll talk about this. For example, so I'll take that example of G only. So again, let me just explain this. So if you have a mass capital M and you have another mass near it whose mass is small m, and if the distance between their centers is small r, right, then according to Newton's universal law of gravitation, F will be equal to G m by r square. This you must have done in class 9, right? So this is the formula for the force between two objects whose mass is capital M small m and the distance between the center is r. Okay, so here G is a constant. It's called universal gravitational constant, right? Now value I have written top. So the value is 6.67 into 10 to the power minus 11 Newton meter square per kg square, right? So if you look here, you can see that this Newton, meter and kg, these are what? SI units, right? We have done about system of units. Yes or no? These are your SI units, right? Newton, when you write Newton, that means you are writing this in SI unit. Okay, so but suppose somebody asks you to write in CGS unit. In CGS unit, what is the unit of force? It's dyne, dyne, right? In CGS unit, the unit of force is dyne, dyne. Unit of meter in CGS system is centimeter, so centimeter square, and kilogram will be gram, so gram minus 2. Understand? So this will be your CGS unit. So again, the value will not be same, right? If you want to express this number in CGS unit, the value will not be same. It will not be this 6.67 in 10 to the power minus 11. You have to find this value. So this dimensional analysis helps us to find this value. Okay, so let us see how. First of all, let us find the dimension of G. Let us find the dimension of G. Dimension of G. How to find dimension? We have to know the formula. So we will use this formula, right? Equation 1. Let me say equation 1. Look at equation 1. From equation 1 we can write G is equal to F r square by capital M small m, right? Now force, we have found the dimension of force on top. It is M L T minus 2. We have so r, what is r? R is the length, right? It is the length. It is the distance between the centers, so it is length. R is length, so you know dimension of length is L, but this is square, so this will be L square 2 times, right? Now M is mass. You know dimension of mass is capital M, right? Another small m, so another dimension for this one also, so 2 m's here, right? So if you solve this, you will get M minus 1 L cube T minus 2. Did you understand this part? Yes or no? Right, dimension of G is clear or no? if you are facing buffering issues, don't worry, okay, you just watch the videos later, because this video will be saved, right, even after the class. So the part that you have missed, you can watch later. Just continue watching. Okay. Yes, any doubts in the dimension of G? Just tell me if you have any doubts. Yes, any doubts? Okay, so that is your dimension of G, understand? So this will help us to convert from SI system to CGS system. We'll see how. Okay, so okay, so in SI unit, let us write everything, and in CGS unit. Okay, we want to convert from SI to CGS, so we'll write this. Okay, now what is the value of G? It's 6.67 into 10 to the power minus 11 Newton meter square per kg square, right? And M1, what is, okay, let us, so you can see here dimension of G has what? M, L and T. So we'll write M1 for SI, L1, T1. Okay, so what is the smallest value of mass in SI unit? It is 1 kg, right, in SI. Same way, what is the smallest value of length in SI? It will be 1 meter. So this will be 1 meter. Same way, what is the smallest value of time? It will be 1 second, right? We'll write that in 1 units, understand? So again, next for CGS, we want to find this value. So this is your value in SI. We want to find the value in CGS. So GCGS. Okay, so we don't know this. We need to find this. So again, we'll write M2 for CGS, L2 for CGS, T2 for CGS. What is the smallest value? CGS means centimeter gram second. So mass will be in gram, length will be in centimeter, and time will be again in seconds only. Yes, this part is clear or not? Is this part clear? Yes, is this part clear? Yes or no? No means no, it's not clear, or what? Type your doubts. Okay, if you write yes, no, I don't understand. You type your doubts if you have any doubts. Okay, so now we will use this. Okay, so see, in terms of dimensions, they will be equal, right? So you can write G M minus 1 L. What is the dimension? L. Look here, I'm copying from here. Okay, I am copying from this part here, right? So G cube T minus 2, right? And this will be equal to your CGS dimension. So M, this will be M1, M2, M1, L1, T1, M2, L2, T2. So M will be again minus 2, cube minus 2, right? So now we want to find GCGS. So I can write GCGS is equal to G and M1 minus 1, L1 cube T minus 2 divided by this thing. I have brought this here, so it will be divided by, so this will be M2 minus 1, L2 cube T2 minus 2, right? I can write like this. So this will become G M1 by M2, same power, so I can write under the same brackets, minus 1, L1 by L2 again same power, so cube, same bracket, T1 T2, and this is again same power minus 2. Right, this part is clear or not? Is this part clear? If not, tell me in the comment section. Is that part clear? Yes or no? Is it clear? Okay. So now we can put the values of m1. So we have written the values of m1, m2 here. So we'll just put that. Okay, just have a look. Okay, so I'm just putting the values. I hope you can see. Right, so m1 is so g, we know the value of g also, it's 6.67 into 10 to the power minus 11, right? And what is the value of m1? M1 is 1 kg. And what is the value of m2? It is 1 gram to the power minus 1. Now this will be L is how much? 1 meter. L1 is 1 meter, L2 is 1 centimeter. I'll just erase this right from the beginning. Okay, I'll write here. Right, so G we know is 6.67 into 10 to the power minus 11. M1 is 1 kg and M2 is 1 gram minus 1. L1 is 1 meter, L2 is 1 centimeter cube, and T1 is 1 second, T2 is also 1 second. Right, now we cannot do anything here, we cannot do anything in this bracket for m, right, because this is in kg, this is in gram, so we have to convert it to the same units. We can either convert, so because we want to find in CGS, so what we will do, kg we will convert to gram. So kg, 1 kg if you know is 1000 gram, divided by how many grams? 1 gram. And again this is minus 1. Meter we have to convert to centimeter, so this will be 100 centimeter. You should know these values, right? 1 meter is 100 centimeter divided by 1 centimeter to the power cube. Now these two I can cancel. If I cancel these two, I'll get 1, so 1 to the power minus 2, right? Okay, 6.67. now gram and gram cancel, and what will be left in this? It will be 1000 to the power minus 1, right? What is the meaning of 1000? It means 10 to the power 3, and you have minus 1 here, right? Again here centimeter can cancel, you will be left with 100. 100 means 10 square, so 10 square to the power 3, and 1 to the power minus 2, what is that? It will be 1 only, right? So 1. Okay, so 6.67 into 10 to the power minus 11, and so what will you get here? You will get 10 to the power into 10 to the power minus 3, because minus into plus is minus, 3 into minus 1 is minus 3, and you will get 10 to the power 2 into 3 is 6. Okay, so what will be your answer? 6.67. now you see here both all the three have the same base 10, so we can add the power. So minus 11 plus minus 3 plus 6, right? Answer will be 6.67 into 10 to the power minus 11 minus 3 plus 6, so 6.67 into 10. So minus 11 minus 3 is minus 14, and if you subtract 6 you will get minus 8. So this is your answer. Okay, so that means here you should get 6.67 into 10 to the power minus 8. Okay, so in SI system it is this much, in CGS system it is this much. We found out using dimensions. Is it clear? Yes or no? Is it clear? Are you sure? Okay, so that is one use of dimensions. Okay, we can convert from one system of units to another, right? See, we have converted from SI system to CGS. Okay, so this is one use. Another use is to check correctness of a physical equation. To check correctness of a physical relation. Okay, so this dimensional analysis will help us verify a formula. If you are given a formula, it will help you to understand whether the formula is correct or not, right? For example, class 9, you must have done this. S is equal to ut plus half at square, right? This is your equations of motion, right? You have 3. V is equal to u plus at, S is equal to ut plus half at square, and the last one is v square is equal to u square plus 2as, right? Do you remember these 3? These are from your class 9, right? Here what is S? S is your distance, u is your initial velocity, t is the time, a is the acceleration, and again t is time. So what is the meaning of this? Suppose there is a object moving on the moving, right, and it starts with initial velocity u, right? It starts moving with a velocity u, right? And after some time its speed increases, it accelerates by small a. Then what will happen? This formula will help us to find the distance. How much distance did it move in your time t? Okay, in time t, how much distance did it move? So this helps us to do that. Okay, so using dimensional analysis, you can find whether this formula is correct or not. Okay, okay, so how does it help us? So see, for this you have to know there is a principle of, for this you have to understand the principle of homogeneity. Okay, I'll explain what is this. Okay, so let me write down first. It says that the dimensions of the fundamental quantities are same in each and every term on either side of the physical relation. Okay, so this according to this principle, it says that the dimension of the fundamental quantities. What are fundamental quantities? Mass, length, time, temperature, electric current, luminosity, amount of substance, right? All those I have explained. So their dimensions will be same in each and every term on either side of the physical relation. So this is a physical relation or an equation, right? So look here, how many terms are there? 1, 2, 3. There are 3 terms. So according to this principle, dimension of S, what is S? S is distance, right? S is a distance, so what will be its dimension? It will be the dimensions of length. So according to this principle, for each term it should be length only, understand? So even this ut is one term, right? So even for this it should be L, otherwise something is wrong, right? In the same way for a t square, a is acceleration, t is time, you should get L after solving. That is the principle of homogeneity. Is it clear? Yes or no? Principle of homogeneity is clear or not? Principle of homogeneity, is it clear? Yes or no? Please type in the comment box if it's not clear. Okay, so I think it's clear, right? So that is the principle of homogeneity, right? It says that dimension of the fundamental quantities should be same in each and every term of the physical relation. Okay, so using this we can check whether this formula given to us is correct or not, right? Suppose you did not know whether this formula is correct or not. So how can we do it? So like I said, dimensions of S is L, right? We already know its distance, so L. Now u is velocity. I told you what is the unit of dimension of velocity? L t minus 1, right? I have told you this also. And one more thing is that t, which is time, so dimension of time is t, so they should be multiplied. Okay, if the sign between them is multiplied, so you have to multiply the dimensions also. Plus half a is acceleration, dimension we already found out, it's L t minus 2, and again t square, t is again time, to t square. Okay, I'll not write half here, okay, because half is a number and does not have any dimensions. I'm just concerned about dimensions here. So now solving this, look, so L t minus 1, sorry, minus 1 and plus 1, right? So what will it give me? 0. So you'll be left with L, right? In the same way here, L t minus 2 plus 2, so again minus 2 and plus 2 will give you 0, so you will get L, right? So from this you can check the correctness. You have seen, right? We have shown that each term is L, right? And suppose this were, instead of square, this was cube, instead of square this was cube, then you would get cube here and you will get extra t here, right? In that case this formula would have been wrong, right? In that case this formula would have been wrong, right? It will only be correct if all the dimensions are same. Okay, and this is your principle of homogeneity. Is it clear? Yes or no? Is it clear? Yes or no? Okay, so that is a second use of dimension analysis. Last one, number 3, to derive a relation, right? To derive a relation. So let me give you an example. Suppose you have a pendulum, right? You know what is a pendulum, yes or no? It is a heavy mass, and you connect this mass to a string. Then this will behave like a pendulum. What will it do? It can swing, right? If you just push it to the right, what will happen? It will reach here, and then come back, right? It will come back again. It will not stop here, it will go this side, it will go to the left, right? It will reach here, right? I have fixed this pendulum from the top, right? From here I have fixed it, right? So this will happen to the pendulum, right? If you swing the pendulum to the right, it goes to the right, and after some time it stops and comes back to the middle. Again it does not stop there, goes to the left, again it will stop here and come back to the middle, right? And this will go on, right, until after some time it stops, but it will go on for some time. So this is called one oscillation, right? What is one oscillation? When you push the pendulum to the right, it goes to the right, comes back to the middle, goes to the left, and again comes back to the middle. This is one oscillation. Okay, this is called one oscillation of a pendulum. Okay, it's nothing but a two oscillation means what? Left right motion, up down motion, that kind of motion is called oscillation, right? So in this case, this is called one oscillation. When it starts from the middle, goes to the right, comes back, goes to the left, and comes back to the middle once again. So this is your one oscillation. One oscillation of a pendulum is clear, yes or no? One oscillation of a pendulum is clear or not? One oscillation is clear or no? Okay, so it will take some time, right? To do this, to complete one oscillation, it takes some time. So that we call capital T. We call that time capital T. It is called the time period. It is called the time period of a pendulum. Okay, time period of oscillation. Time period of oscillation of pendulum. Okay, understand? So using dimensional analysis, we can find a formula for T. We can find a formula. How to find the formula? Okay, so first of all, we have to know your T can depend on what things. What are the things on which it can depend? Number one, see. So let us say this. So this is called a bob, B-O-B, right? This is called a bob, and this is a string, right? The string is light. Okay, its mass is 0, almost 0. You can say its mass is 0, but this bob has some mass. Let us call it capital M. So time, so your time can depend, number one, on mass, right? It can depend on the mass of the bob, mass of pendulum. You can say mass of pendulum, mass of bob is same because the string has almost 0 mass. Number two, it can depend on the length of the pendulum. So this is your length, right? This is your length. It can depend on length of pendulum. And last one, you can depend on acceleration due to gravity. Why? Because see, why does the pendulum stop here and come back? It's because of gravity, right? It cannot go up. If it goes up, gravity pulls it down, right? So gravity is pulling the pendulum. That's why it comes back to the middle, goes to the left, comes back. It's because of gravity, right? So it depends on gravity. So gravity, specifically the acceleration due to gravity, it depends on the acceleration due to gravity, right? Which is written with letter G, right? Again, this you must have studied in class 9. If you allow any object to fall on the surface of the earth, right, that object falls with an acceleration G, which is called acceleration due to gravity, and the value is 9.8 meter per second square, right? So this is not very difficult to understand. You have a chapter of gravitation in class 11, so maybe when we do that, you'll understand this better. For now, just try to get a brief idea, right? So your time can depend on these three things. One is the length of the pendulum, another is mass of the pendulum, and last is the acceleration due to gravity. Is it clear so far? So far, any doubts? So far, any doubts? So far, any doubts? Yes, quick. Any doubts so far? No doubt. Okay. So see, so it can depend on these three things, right? So I can write. So mass of pendulum is capital small m, length is small l, and this is G, right? So let us say your T is proportional to m to the power a. That means T is related to m to the power something. It can be m to the power 1, it can be m to the power 2, it can be m to the power 3. In the same way, let us say T is related to L by this relation. It's directly proportional. This symbol, I hope you know, directly proportional means if this quantity here MA increases, this will also increase. If this one here increases, this will also increase. Okay, directly proportional means they are related to each other by this relation. That means if one increases, other increases, and if one decreases, other decreases. Okay, now third one, acceleration due to gravity, let us say it is gc. Okay, so combining these three, I will get t is proportional to m to the power a l b. I'm writing together, understand, it is the same thing, right? Now what is the dimension of t? T is time, right? I have told you dimension t is time, so dimension of t will be capital T, right? I will remove this proportional sign here. So proportional sign, so this sign is called your proportional sign, proportional sign, right? If I remove this, I will get an equal sign, and along with that I get a constant. Let us call that constant k. Now m is mass. What is the dimension of mass? Capital M, m to the power a. What is the dimensions of length? Capital L, n to the power b. Now g, what is g? G is acceleration due to gravity, so it will be the units of acceleration only. What is the units of acceleration? Lt minus 2. I have explained this, so it will be to the power c. Okay, now this thing, so let us combine all these. So m to the power a, so this is m to the power a, lb, and again lc is also there, and t to the power minus 2c. So what will I get? So k, this will be m a l b plus c and t to the power minus 2c, right? Now this one, so k. Now look here, so ma, so this is ma l b plus c t minus 2c. Now look, compare these two, right? Do you see any m value here? Do you see any m value on the right? No. So what does this mean? This means that m has power 0, right? Do you see any l value? No. So l will also be 0, but you have t, so t is 1 in this case, right? So k, so ma l b plus c t minus 2c, right? So now compare these two. You can see a is 0, b plus c is also 0, and last one minus 2c is 1, right? So from here I can see c is minus half, right? And from here I can also put b minus half equal to 0, so b will also be half, right? A is so we have found the values of a, b and c. This is what we need. If you want to find the relation, this is what we need. Okay, so now we can do. So what did we get? We got t is directly proportional to m a l b g c, right? And if I remove the proportional, okay, so now let us not remove the proportional sign here. So what is a? A is 0, so m 0. What is b? B is half, and g is minus half, right? So t is proportional to, so m0 does not carry any meaning, it means 1 only, right? Anything to the power 0 is 1, right? So instead of m0 I'll not write anything. What is the meaning of half? Half means root, right? To the power half means root, so this will be l root l, right? This will be root l. Now g to the power minus half, this will be g half, right? If I take it down, if I take it to a denominator, minus will change to plus, so you will get this, right? So together I can write root l by root g, right? So t is directly proportional to, if I write together, l by g, right? So from here you see this is the formula for, not the formula, but this tells us that t depends on l and g by this relation, root over of l by g. Okay, if I remove the proportional sign, I get a constant k, and again l by g. So by experiment it is found that k is equal to 2 pi. Okay, so the formula for t will be 2 pi root over l by g. Okay, so you see we have found a formula for time period. It depends on what? Length of the pendulum and the acceleration due to gravity. How? To the power half, right? Root of this. Is it clear? So we do not know anything, but from there, from dimensions, we have found this formula. Is it clear? Yes or no? Is this part clear? How I found the value of t? Is it clear? Yes or no? Okay, so just type your roll numbers in 1 minute quickly. I'm giving you 1 minute. After that I'll not take the roll numbers. Roll numbers, not name. Don't type your name. I need roll numbers. Okay, that's it. Okay. Okay, so what I wanted to say is that if I have went too fast, you just watch the video again. Okay, the video will be there on YouTube. If you click the link that I have sent, you can come to the video. So click on that, watch it, and if you have any doubts, we can discuss it. So I'll give you some questions on this. Okay, I'll give you some questions on this topic in the evening. Try those, and if you cannot, then we will discuss tomorrow. Is it clear? Any doubts? Any doubts? Okay, if I have went too fast, just watch the video. The link will always be there, so you can watch. Okay, so that's all for today. You can just watch the video once again if there is any doubt.